Hi everyone, hope everybody's doing okay. So I've gotten a lot of questions about Midpoint Karel, and for a very valid reason. It's actually quite a hard problem to solve. So after spending a solid 2 to 3 hours trying to come up with a solution for this, I think I finally have an answer. So I'll give you a step by step of how I came to the solution that I came to, but there's going to be many different approaches to this. So let's first go through the question itself to understand what we have to do, and then we can start to come up with an algorithm first, because unlike all your other assignments where you were told how to approach the problem, like you were told that these are the things that you need to do to get to a solution, in Midpoint Karel, they've just told you that you need to find the midpoint. How you do it is up to you. So first step, you come up with an algorithm to solve the problem, and then from there you try to implement that algorithm. I did try to implement one of these algorithms with Ashley today during the optional class, and I was not able to come up with a solution using that algorithm, so I switched my approach. But if you guys are coming up with solutions using different algorithms, please feel free to share it in the forum as well so others can learn too. You have to find the midpoint of the first trait, i.e., the first row. So you're gonna have to come up with a solution that finds the midpoint of the first row in all these worlds. It should be a solution that you can use in any kind of world. So, for example, in this 5 cross 5 world, the midpoint would be here, right? This would be the midpoint of the world, and you need to put a beeper there and get Carol facing east. This is the solution that's required. In case of an even world, um, yeah, here it's written. The world need not be square, but you may assume that it is at least as tall as it is wide. And if the width of the world is odd, Carol must put the beeper in the center square. That's clear, as we've seen in this example. But if the width of the world is even, Carol must drop a beeper on the leftmost of the two squares. So in the case of this 6 cross 6 world, we have two center squares. So Carol would have to drop the beeper on this left square here, right? Okay. So now, what are the possible ways in which we could do this, right? So now, one of the algorithms that people are using are that so Carol would put a beeper on the first end of the world, move to the next end of the world, put a beeper, turn around, again move till here, put a beeper, turn around, move to the next end of the world. It's going to keep doing this till it reaches the center, right? So getting with this, okay. So now put beeper, and finally whatever's left is going to be the center point, right? So once they found the center point, they're going to put a beeper there, and then they're going to delete all the other peoples, right? So that's one approach. That's the approach that we try to follow, me and Ashley, but it was proving to be quite difficult for me. So I decided to go with another algorithm, right? So in this algorithm, the solution that I have chosen, in that what I do is I initially place beepers across the entire row, and then I start picking off beepers from each end, right? So essentially it's going to put beepers across the whole row, right? And then you start picking up beepers from each end. So pick beeper from here, then turn around, go back to the other end, pick beeper from there, then turn around, go back, pick a beeper, turn around, go back, pick a beeper, and then turn around, and you have the solution that you need, right? So this is the algorithm that I chose to try to implement. And now we'll go into how we can write this using the Carol functions. Okay, so first things first, when you think of this, we understand that our first function that we need to implement is fill row, right? I'll write these things down. The first thing we need to do is we need to fill a row with papers. After that, I'm going to choose to go back to the start just for clarity. So move to start. And then we are going to start our shrinking, right? So we're going to start removing papers from each end. So shrinking. Okay. So to implement this, I've already written the fill row function, and I've already written the move to start function. These are things that we've already covered before. So essentially fill row, you put the beeper while front is clear, move put beeper. So the entire row will have beepers. Then move to start, turn around, and come back to this position. And I've also included a turnaround, so so that Carol is facing east again, right? Okay, let's see how that works. So we can see that the fill row is happening, and Carol's going back to the start and is facing east again. Now we need to come to the shrinking part. So I'm going to change the shrinking, like essentially we just need to remove from each edge, right? I'm going to change this into two functions, one for the corners and then coming in, compressing in from after the corners, right? So for the corners is quite simple. Let's say corners, and I'm going to call the other function, let's say edges, right? For like corners include removing this beeper and this beeper. And then after that, the shrinking function to remove everything else is going to be quite similar. For these two beepers, it's going to be similar because they're at the ends of the world. So we can use while front is clear and then pick beeper. So that works easily for the corner ones. Whereas for these, for anything after the corners, that won't work, right? Move while front is clear and pick beeper won't work for these because these are not on the edge of the world. So Carol is going to move ahead of them. So that function won't work here. So I'm going to create a separate function for these. When you're able to visualize it, it'll make more sense. Okay. Now for corners, right? I've written the functions already. Okay. For corners, you're going to pick this beeper here. Then you're going to move while front is clear. So that's going to take you till here. And when you finally finish moving, you're going to pick beeper. Now you're done with your corners and you want to go and start shrinking from the edges inside, right? So we've also included a turn around and move. So essentially what it's going to do is it's going to pick this beeper, and then we're going to stop here in this part over here, right? So let's see that. So that's the fill row, move to start. And this is remove corners. And then it comes to the edges of the other beepers that we need to remove. Okay. Now, how do we deal with the edges, right? So in this case, already we know anyhow we have to pick that beeper up, right? Then we need to move till here, and we need to pick this beeper up, then again move back. But let's for now focus on picking this beeper up and moving forward. So how would we do that? Let's create a function, define edges, right? Okay. Now again, we need to pick the beeper, then we need to move till the end of beepers. By that I mean move till here and pick that beeper. So how would we do that? Okay, so for the first pick beeper, we just use the pick beeper function. Now, how would we move till there? So if we look at the functions of Karel that are available to us, we can see that the best possible thing that we can use here is while beepers are present, right? So while beepers present, move. So while these beepers are present here, okay, if you look here, there's a flaw in what I've just written, right? Once Carol picks a beeper from here, there's going to be no beeper here. So when it goes to the next line of code, while beepers are present, move. Initially, while beepers present, is there a beeper there? No, because we just picked it up. So then it's not going to go into the while loop. So we also need to include a move statement here, right? So pick beeper, we've picked up this beeper, then we'll move to this position right here. And then we're going to go into the while loop. While beepers are present, move. Now let's see how that works. Okay, I think there's going to be an error because I've already written the edge function edges. Okay, I'll change this to edge for now. Right, okay, let's run it. So fill row, move to start, corners, and this. Okay, so we see that when it executed the edge function, right, it picked the beeper, it moved forward, and then while beepers are present, this condition is true, keeps moving, keeps moving, keeps moving, keeps moving. And when we reach here, while beeper is present is true again. So it's going to move to the final corner position. But we needed to now go back to the edge, right? We have already dealt with the corners. We don't want to deal with the corners. So in this case, we're going to just include a statement for the situation when it goes to these empty places where there are no beepers present, right? So if beepers, if no beepers present, then please turn around and move forward so that you are at a location with beepers, right? So let's see how that works. Fills row moves to start, corners. Now edge, yeah. So it picked up this beeper here and then it moved till here. That's what this while loop, it moves till here, right? And yeah, let's look at that. After the while loop, it reaches the final corner. Now to move forward from there so that it can keep functioning. Otherwise, if we're in that position, we've already dealt with the corners. We don't want to deal with the corners again. So we want to move ahead of the corners. But like essentially just think of it as corners, we've removed beepers. So the way to find out is if no beepers are present, that means we're on the corner, turn around and move forward so that we're shrinking again. So now I'm going to turn around and move. Okay, so now we're going to be shrinking this again. So now to shrink this, if you think about it, it's the same thing. We need to pick a beeper, move, and while beepers are present, we need to again move to this edge, and then we need to do the same thing over and over again. So you're repeating something. So we'd have to do while some condition, we need to call edge again, the edge function again. So what exactly would be the condition here? Right now, let's check if we can do this with while beepers are present, right? Because essentially we want to keep repeating this shrinking function as long as there's beepers in the row till we reach that final position, right? So while beepers present, we call the edge function again. Let's see what this does. Okay, that's the first edge function. Okay, seems to be working. Oh, but now we see something that it's removed all the beepers, including that beeper in the center position that we wanted, right? Okay, so we can see one of the executions here. While beeper is present there. So it's going to go to the edge function. It's going to pick beeper, it's going to move. And while beeper is present, it's going to move. Beeper is present is there. And then there's again going to move. If no beepers, turn around, move. Okay. So this is now our center, let's say center beeper, and this is where we want it to be. And Carol needs to be facing east as well, right? As we saw in the question. So now we essentially have what we want. We can just make Carol turn. However, we see that that's not what's happening, right? In the function, the edge function, it's going to move again because beeper is present, and then it's going to turn around, right? And then it's going to pick this beeper up as well. But finally, we see that it ends up in the center position itself, like after everything. So all we need to do now is we can do, we're in the center position. Even though it's removed, it goes back to that position. So we're going to now put a beeper there. And we're also going to ask Carol to turn east. This is a function that I've written already to face east. If in this situation, Carol is either going to be facing east or west throughout the program, right? So in the condition that Carol is facing west, then it needs to turn around and face east. If it's already facing east, the function won't do anything. So that's a good function to have because in even and odd worlds, depending on how many positions are there, it could be facing east or west. So in certain, maybe in the odd world, it could be facing west. So it's better to have a face east function here. At least it's a bit simpler for me. So let's see now if we're able to get the code how we want it to be. Okay. And now it's removed the center one, but it goes back, places it, and faces east again. So now let's check this code and see if it works, right? This is just an empty ID. This is the question portal. I'm going to put it here. Now, okay. So we get a warning that says Carol finished running but didn't solve the problem. Check the world 2x2. So let's go to 2x2. Let's run it. Okay, so we see the problem very clearly here. In an even world, as they mentioned, Carol must drop a beeper on the leftmost of the two squares. So the beeper is supposed to be here, not here. Now let's see if this problem is the same for all even worlds or is it just the 2x2, right? So let's check. Okay, for the other even worlds, it's working fine. In this case, again, these were the two center and Carol needed to place it here and Carol has placed it on the leftmost. So it seems like we only have an issue with this 2x2 world. So this is an edge case or a case that may not come up naturally, but we need to think about this now. So how do we deal with that? Because the functions are all working for odd worlds, even worlds. It's only this one world, right? So let's just, in this case, if it's an even world, I mean, if it's a 2x2 world, we know that it needs to be in the first position. So let's just like explicitly state that in a 2x2 world, it needs to be here. In every other world, this code is working. So now to do that, in our main function itself, we would try to do something along the lines of, how do you know if it's a 2x2 world, right? Think of the functions that we have. Okay, so Carol can move forward while front is clear. So in this position, is front clear? Yes, Carol would be able to move forward. But in a 2x2 world, the front is only clear in one position. The second, if front is clear, would always be false. So we can use that to our help here. So we can write, if front is clear, move. Now, if front is clear, is true. So in this case, if front is clear, that means you're not in a 2x2 world, right? I'll just explain that again. If front is clear, move. We are just going to go to this position over here. Now, if front is clear in this position, it means we're not in a 2x2 world. We're in any other kind of even or odd world in which the code that we had is already working. So for that case, you would just use this condition itself, right? So this code would work there anyway. Now, in the other case, if front is not clear, it means we're in a 2x2 world. So in this case, oh, right. But our assumption for fill, row, move to start, everything is that we're in the first position of the world, right? Here we've moved and we're in the second position here. Right now, if front is clear, move. So we are here in this second position, right? And our code starts from the first position itself. So we need to go back to the start. So we can do move to start and then the rest of the code. Now, if it is a 2x2 world, then you're going to, since you're in the second position, you need to move back to the first position, put a beeper, and you're done. So you're going to move to start and you're going to put beeper. And I think this should work for us. Let's see what happens. And it has worked. So that is the whole problem. I'll put up this recording on the forum. So if you have any doubts or any questions about any of the functions, just scroll back and go to it and just imagine it. Like I've given you the algorithm in the start already. I've implemented it in my way. If you can find other ways to implement it, that also works. And if you're using other algorithms, that's also really great. Feel free to share it here so that maybe we can see different ways to solve the problem. I'll also put up a few links of solutions that I've seen on YouTube, etc., of different ways to solve this problem, different algorithms. So you can go through that as well if needed. Okay. Hope everybody's doing fine. Thank you. Bye.